Hello everyone, I'm Casper. I'm the founder of Testimony, where we help our clients make sure that they deliver their software fully cooked instead of half-baked. And here on YouTube, we help aspiring QA engineers and people of all trades become test automation engineers one slice at a time. And today we are going to focus on a very important question, one that also comes up in interviews very often and is in general a very important thing to ponder for a minute about. And this question is, should we automate everything? Let's jump to our whiteboard. So this question is very important because you may think, all right, so if automation is that great, if it's like the cool kids toolkit, so should I use it every time I can? So isn't that the solution to all our problems? Isn't that the end all be all solution to every problem we have with quality assurance? Isn't it that automation that should be employed in every possible situation and it's just the end of QA as we know it? Isn't it that we should just automate everything, just have it done, and then we don't need testers anymore? Like, what would we need them for? So it's not that simple. And you may think that, all right, so since we know how to automate tests, maybe let's automate everything, and then we don't need to have this human component in our equation. We don't have to worry about whether someone makes a mistake, like the machine doesn't have a bad day, so maybe let's just stick to that and let's just automate everything. So sadly, or not sadly for us, because we will still have jobs, maybe thankfully, we should not really strive for automation of everything. And to be honest, a 100% coverage with automation is neither possible nor should it ever be your goal as a QA engineer or as anyone within the project. And during this episode, we'll try to answer why that is. So you need to understand that, yeah, the frameworks are good. We are getting better and better tools in our toolkits, but still the technology is only so good. Like, we still need that human component. We still need people overseeing this whole process. And today we are going to talk about why that is and what exactly is the whole issue here. Why don't we just solve everything with technology here? And so the main thing that I would like to outline, and basically this answers the whole question, but as it goes with our videos, we will talk a lot about that, but the main principle that you should think about when thinking about whether something is a good fit for automation is it repetitive? Is it predictable? And is it tedious? And to be honest, I think that this here equation basically covers all scenarios. Like, it tells you everything you need to think about when you try and answer a question of whether something is a good fit for automation. So let's try and break it down a bit. So the first thing is repetitiveness. So why is it important? It's important because it's still a machine. It operates on algorithms. It doesn't really operate on like having a hunch on something or thinking that something might be a good idea. Like, we are getting that with this whole AI thing going on. But of course, as it goes with like real production ready tools that we are using, they still need that repetitiveness. So they need to have a specific set of steps that they are going to work on, a specific set of steps that they're going to execute in order to actually know whether something passed or failed, whether the instructions were clear enough for it to execute them in a manner that also correlates with what the tester thought it would entail. So the repetitiveness is a very important first step. So you need to have a test be such that you can express it as an algorithm, as a set of steps. You can think of it as a set of steps because people are sometimes afraid of terms like algorithms, but an algorithm is like a cooking recipe is also an algorithm. It's just a set of instructions, one after another, that need to be executed in this specific order. So that's what automation does. That's what the automated tests are. In principle, they are just programs, scripts, a set of steps, an algorithm that needs to be sequentially executed in order to run. And so you need to have something that is repetitive, both as far as the way it works under the hood is concerned. So this is what we have talked about, but also repetitive in the sense of the project as a whole. So it is repetitive in the sense that it is going to be executed pretty often, or at least at some predictable intervals. So this is the whole sense of repetitiveness. It needs to be both repetitiveness inside, so a set of steps that you can precisely tell the algorithm to do, and it needs to be repetitive in a sense of the project as a whole, because it needs to you need to have the knowledge that it'll be run again. If it just runs once, why do automation for that? Like if it's a test that most likely will be executed once because they are testing something new and most likely tomorrow will be different, then why bother creating a separate automated test for it? For automated tests, you need to create them, you need to maintain them, you need to make sure that they work. They are time consuming and they are resources consuming. So you can't really do that just because you have some quick thing to test. It'll be quick checks are just that. They're quick checks. You don't need to create a whole automation suite for them. So that's the nature of repetitiveness. As for predictability, it comes down to, in part, what we have talked about in repetitiveness, the inside part. So it needs to be predictable in the sense that you need to be able to express what it needs to do in the terms of specific steps. But again, it needs to be predictable in the scope of the project. So it needs to be predictable in the way the environment works. It needs to be stable. You can think of this predictability as stability also. So it needs to be predictable in a sense that it also operates on stable foundations. So it needs to have a stable environment. It needs to have stable locators. It needs to have a stable chain of command, like what exactly is executed when. It needs to be predictable in the way that it does its whole work from running to validating the final responses. So it needs to be predictable in such a way, because if it is not, then a machine is not going to be useful for that. You can't really expect the machine to operate on unknown territory, which you often do as a manual tester. When you are doing exploratory testing, for example, or when you are testing new UI, which may change anytime, then you are checking things which are not yet set in stone. They are not well documented. You can't really express them very often. You learn as you go. You employ your human creativity as a part of your process when you are a manual tester, and you can't really expect automation and frameworks to do that for you. They are still, at the end of the day, they are just using a set of commands you provide to them and a set of rules to finally, eventually, somehow validate the result in order to tell you whether something works or not, whether it passes or fails. So you need to have it be predictable, and you can't do that if the environment is unstable. You can't do that if the application is unstable. So you need that predictability. And as for the tedious part, again, I use tedious as a sort of umbrella term for many things, because tedious in the sense of time consuming for the human to perform, tedious in the sense of using a lot of data that you need to provide every time you do it, tedious in the sense of complex, like entailing complex calculations or some operations which are just cumbersome and just weighing on people to do them. So this is what tedious means in this whole equation. So tedious can also be referred to as complex, for example. So tediousness is also, it's an umbrella term for all the things that are just pain to actually run as a tester manually, both because of being time consuming or energy consuming, or which are just constructed in such a way that being a manual tester, when you are doing them, you just think, oh, that's a good analogy. Every time you perform some manual testing and you're thinking like, oh my God, a monkey could do that. Oh my God, why isn't a computer doing that? Oh my, why am I wasting time on just clicking through these things? These are tedious tasks. So these are tasks which are so obvious to you as a human being. They are so glaringly obvious that they could be expressed in a way that that a machine would understand very often. So this is the nature of tedious in this equation. And so, like I said, I think this basically answers all the questions over whether something should be considered a good fit for automation or whether it should not. So we will refer to that as the RPT test. So the RPT, because repetitive, predictable, and tedious, it basically answers all your questions. So let's think about why we need all three of these components, because that's where things get fun. So maybe let's change our color. So let's say we have R and we have P, but we don't have the T. Let's say we have repetitive and predictable tasks, but such which are not tedious. So let's think about that. Let's say you have a test that is being run pretty often. It is predictable in the sense that the whole environment is stable, but it is not complex. So, for example, you have a quick check of something that needs to be done pretty repetitively. For example, every release, it is predictable in the sense that it is performed over a stable, or hopefully stable, application at that point, but it is not tedious. It takes like 20 seconds for a human being to validate it. Like, let's say it's whether a PDF report actually that is auto-generated after like every quarter contains the expected headers and the expected elements inside. So this is a thing which is repetitive because it happens every quarter or every release or something like that. It is predictable because you could find a way to tell the machine how to do that. It's stable at that point, so it is predictable, but it's not tedious. It takes like 30 seconds of the tester's time. It takes like 3 minutes. And so, yeah, you could automate it, and it could take like however long it takes outside of control of a human being. So it would free up the efficiency of that particular employee, of course. But it's so not tedious that very often it's a good idea to not automate it, because even though it is repetitive and predictable, it may be that it entails so much overhead when creating automation that actually creating a test for that would take so much time that the time lost in creating the whole script, in maintaining it, in making sure that it works, and in validating it, and the whole shebang, it actually may overweigh the benefits of the automation. You may never make up in time the time that you have inadvertently lost on creating it and maintaining it and keeping your eye on it. Because for automation, you have to remember that it's not like you create a test and you forget about it. You have to periodically come back to it. You will sometimes get false positives, false negatives. Sometimes things will go wrong. Sometimes things will change. Like if the formatting of the file PDF, for example, changes, for a human being, it's as simple as asking once, oh, has the format changed? And your PO, for example, will reply, yeah. So now the colors are all different and the orders all different. Just don't care about that. Just check it if it's okay. And it's enough for a human being. For automated test, this communication that has just happened already means rebuilding this whole thing, sometimes from the ground up. And so it takes a lot of time, and even though it is a good fit as far as repetitiveness and predictability are concerned, it may very well, the tediousness may very well not be enough for us to warrant actually having an automated test for that. So this is this scenario. Let's just say that we have repetitiveness and we have the tediousness, but we don't have the predictability. So this is the classic situation of exploratory testing that we have talked about a moment before. You have something that is repetitive because, for example, there are some changes done in the UI and you still need to validate whether the application is functioning properly. So it is repetitive because you still need to periodically run your tests, or someone needs to check it manually. It is tedious because you, as a human being, are seeing this application for the 1,000th time and you are still checking the same things, and you are just really fed up with all this, the same application flows and stuff like that. But it is not predictable because, like we talked in the beginning of this scenario that we're covering right now, it is an unstable UI. So you don't really know how to program your script to actually reflect those changes. It may be that the changes are so frequent and so breaking that the script will not keep up. The locators will break. The script will just get lost. It'll throw some errors, exceptions, and so the automation will be of no use. You will spend more time fixing the automation that you would spend actually testing. So in such situations, very often it's good to test it manually still, and either do some very brief overview of how the automated tests may look like in the end, or not do it altogether until the works on the UI are actually finished, or until there is some documentation at least and designs over what they should look like in the final version. Because using up your time on automating at this stage very often just is a time sink. You will still need to test it manually because it needs to be tested. So the fact that your automation suite is not working isn't going to be enough, and still work on your automation suite, and you will just be attacked on both fronts. So very often it is not a good idea. And so when something is repetitive and tedious, but it is not predictable, the environment is unstable, the application is unstable, the environment, for example, frequently has some crashes and stuff like that. And as a human being, you know that, oh yeah, sometimes I just need to refresh it a couple of times. Or yeah, I need to just come back at a different time. Very often, it's not that easy to convey that to a machine. And so if predictability is lacking, very often it's a deal breaker for creating automation for such a scenario. And the last thing is, what happens when something is predictable and it is tedious, but it is not repetitive? So this is a classic scenario of like a quick change or a quick test request that you get from someone, from the team. So very often it may be that there is something that is predictable in the application, the environment is stable, you can actually express it as a set of steps. It is tedious in the way that you have already done this or a variation of this 8,000 times, but it's not repetitive. Like, there is no real need for it to be run periodically. There is no need, for example, to ever have this run again in a foreseeable future, or it will need to run at some time in the future, but you're not really sure when. It may be in a week, in a month, or in never. So in such a situation, it's also not a good idea to automate it. Because again, remember, automation brings overhead of time, energy, maintenance, and then keeping this script clean and working as it should. And so as a consequence, if something is not from the get-go expected to run repetitively, even rarely, but repetitively, then usually it's not a good idea to automate it, because why bother? Again, you are creating a time sink for yourself for something which you may see only once, or something which you may need to repeat a couple of times. But for example, only once. Like, let's say there's an intensive period of testing some new feature that happened, or a UI element, and you have, for example, a couple of days during which you need to check this thing every day because the changes are so frequent. The devs are pushing it very frequently, and you need to do it every day. So yeah, all right, it is repetitive, but it is repetitive over a short term. And the repetitiveness that we are talking about here is repetitiveness over a long term. So it's not like the fact that you repeat some test at least once already warrants the need for automation of that. It may be that you need to repeat some tests like 20 times, and it's still not a good fit for automation because it's going to be 20 times and then never again, or because a feature is dropped, for example, or a UI change doesn't quite cut it, or they decide to change the designs, they decide to change documentation, and suddenly the repetitiveness over a short term doesn't mean anything anymore. Because yeah, it is repetitive, but you are not going to repeat it ever again. So in that situation, no dice. You shouldn't automate it. And so it is not a good fit. And that's why it's so important to have all three of this, of this equation. If you don't have any, if you have any of these lacking, it's usually in 99% of the situations, unless, of course, the project demands it for some reason, which may not be logical, but let's not get into that right now. So whenever you feel like all three of them are not really there, then you probably shouldn't proceed with automation. And we will talk about this over some examples now, but I just want you to remember your automatate. Whenever something is repetitive, predictable, and tedious, it is almost always a good fit for automation. And these corner cases are so rare and very often so imaginary that you shouldn't really bother with them. So just remember that. If any of these is lacking, there's usually a very good or a very good reason why you should not progress with automation in order for that not to be a time sink, both for you with work that may just go and perish one day, and for the project, which may lose you and your resources over something that is not going to stay, or it is going to stay in such a way, shape, or form that it will need to be reprogrammed from the ground up one day anyway. So let's just progress to some examples to see our automatate in action. So, for example, let's start with good fits for automation. Good fits. So number one, and this is the prime example. This is like the end all be all. If you want to have a good hunch of what is a good fit for automation, it's regression. So regression is perfect for our demonstration because it is something that is clearly defined. It is basically doing retests of the same thing again and again and again to the point of headache. It just means running the thing that is already well established, something that is already well defined, documented, you know the designs, you know how it works, you know how it looks, you know everything about it. The only thing missing is that you are still doing it. So this is a very common headache that manual testers have expressed with workshops or at workshops or during some sessions with me, that the regression is just so tedious, it is so repetitive and so predictable that very often they feel like they're sleepwalking through this process when it comes. And so this is why regression is a great idea for automation, because regression in most situations, sometimes we might have some, like I said, corner cases where, for example, you need to every time configure some external tool during your regression tests, for example. And in this way, the automation thing is a little shaky because you may not be able to automate like some external CMS which you do changes with during regression and stuff like that. But in general, in most scenarios, regression is perfect for automation because it's clearly defined, you know what to do, you've done it 1,000 times, and so have all the QA engineers in your team or company, and you just know what to do, like to the dot. You can express it and specifically tell the script what to do in order to progress with it, and the final verdict is also clearly defined. You know that when something happens, then it is okay. If it doesn't, it's not okay. It is as simple as that. And in such a situation, regression is perfect. It's a perfect fit for automation. Number 2 is non-functional testing. So I am also using this as an umbrella term for all the things that humans may have trouble with executing or interpreting the results of, or they may just be worse than machines with performing this. So this is like your load testing, your performance testing, sometimes security tests also. So this is just things which humans can do, but they are either worse at doing or interpreting it, or they are just not able to execute it properly. Like as a human being, it's way easier for a machine to simulate a load happening over an application and then measure specific metrics over it, rather than a human being trying to simulate it. So non-functional testing is also great for this reason. And it's also like a very specific niche that the machines, apart from doing your RPTs, the machine also has some specific capabilities of doing it. Like, for example, being able to simulate a lot of agents and stuff like that. All right. So number 3 are going to be your data-driven tests. So these are things where, for example, you need to iterate over a large body of data. For example, you need to input a lot of different data in different variations and permutations in the forms, or you need to like try and log in or register with different sets of data, some of them correct, some of them incorrect. You need to try and test your fields with various combinations of things. So the data-driven tests are perfect for this because very often they are extremely tedious. So as long as they are repetitive and predictable, which also very often it is not only the test is not the only thing to blame here, because very often the predictability problem may be due to your application or due to your environment and stuff like that. So you need to keep that in mind also. But if those criteria are met, then the tediousness criteria is like sky high with data-driven tests, because no human being is going to iterate over such a large body of, for example, data, credentials and stuff like that as a machine. Of course, you can try to scale that up by just employing more human beings, but very often it does not really scale that well, because you get to a point where you have an army of people doing your data-driven tests, when a well-created script may actually do it way faster, way more reliably, because it won't make any mistakes. Just all around, it'll be faster, more efficient, and less prone to error. So very often companies do tend to, at some point, scale up the count of testers in order to cover more and more data points. But very often, one automation tester is going to create a test with some overhead, for example, because it'll take some time, but a test which will do a work of 100 people in a very short time, especially when it's run in parallel, for example, and with basically no proclivity to errors. So data-driven tests are also a perfect fit. Another thing are, since we talked about parallelity, like parallel or cross-platform tests. So you may have situations, and basically in all projects you do, when performing cross-platform tests are an important part of the testing suite. So you need to not only check whether the application works and looks and behaves like it should, but you need to test that over some collection of possible platforms that it is going to be experienced on. So very often it'll be like desktops and mobiles, for example, but this will branch even further depending on the size of the project, because it also entails costs very often. So it'll need to be tested like very often on physical devices provided to you by the company, or through simulators, like the browser stack, for example, provides online simulators of a lot of different platforms. And so you may need to actually run it over a very large collection of devices in order to make sure that your application behaves well on different operating systems, or different screen sizes, or different resolutions, over different gestures supported by a given application or system. So by cross-platform, I mean cross-platform, cross-browser, cross-OS, cross everything. If you were a tester already and you are doing QA engineer things, very often you are doing this by hand right now. So very often it is, again, that the companies go for just creating more workplace for people to actually do the cross-platform things, when a well-prepared automation suite may actually do the work of 100 other people which are clicking through the stuff on the simulators, which again may break, may not work exactly as intended. People may make mistakes and stuff like that. A well-written script will do it for you, even very often with the same specific tool. So like Browser Stack, which I mentioned, has both the simulators online, which can simulate very different like scenarios and platforms, OSs and stuff like that, but it also has an automation suite. So you can also leverage the simulators for your testing by creating automation, which will run in parallel by doing the same stuff on 1,000 of different devices. So it also allows you to cover a way large pool of devices than just employing more human beings would help you. And it goes also for the parallel tests. So if you want to run tests in parallel, again, you may just hire more testers. Like, that's a way of doing it. And very often a way that the companies go for. But you can also just have some library which allows for the test to be run parallel. And then you have parallel testing performed by the machine, actually. So in such a situation, your tests are, again, repetitive, predictable, and tedious, and you want them to run even faster. For example, you may go for parallel tests, and in this situation, you need to have automation in order to do that. Automation will allow you to run it in parallel, and very often it will be only limited by the horsepower that you have. So the performance of the final tech solution that you go for regarding the like servers and computing power. So these are the fits which are good for automation. But of course, like we talked right from the beginning, there are also things which are not that good. So let's now talk about bad fits for automation. And number one, lo and behold, is going to be, which we have already covered a bit, exploratory testing. So, like I said, exploratory testing is something that entails human creativity, this exploration gene we all have. So even if something is not perfectly documented, we may infer the meaning of the elements from the other things. We may just try to do it because we know that on other websites it works like this, or we may remember that in a previous release of the application it works like that, or we may remember that on Slack or Teams or wherever a team member actually talked about some proclivity of the application to work in a given way. So we may cut it some slack, or we may actually know which way to go. We also learn as we test. Very often when you do exploratory testing, you find out the bugs which are not even in places which you were supposed to look at. You may very often just explore the application, go through it, simulate a real consumer, learn as you go, and then suddenly just find an error, find a bug, find something to report. So this is not really a good fit for automation, because like we talked in our RPT our discussion, it is not really repetitive, because exploratory testing is also by definition something that just may sometimes happen out of the blue when you are doing something completely different, and it is not predictable in the least. It is not predictable very often because exploratory testing also happens on new features, and also not really predictable in the sense that it is also not something that you can express as a set of rules for an algorithm, because you can't really tell the machine, yeah, do this, but remember that Michael told us something like that, and remember that Philip said that, like, until next week it may not work properly, but you should still just progress. Oh, and also, if you find another bug, just report it. So this is something that you can't tell to a human tester. You can't tell that to the machine. You can't tell that to your framework. You can't really, you can try to simulate some of these things. Like, for example, you can use keywords in a robot framework which allow it to progress even if something breaks, when something is known to sometimes break, but it's not crucial, for example. But still, it is not really an end-all be-all solution. Still, the exploratory gene is not really possible to simulate right now in the frameworks that we have, in the tools that we have as automation testers. So exploratory testing is not a good idea for automation. Secondly, it's UI and UX testing. So this we've briefly touched upon also a bit, but to elaborate a little, UI and UX are stuff which are designed and implemented precisely for the reason that it is an application made for human beings to interact with. And so when you employ a machine to do testing of these elements, and I'm not talking about like just checking whether everything is perfect to the pixel with the design, because for this a machine is great. It'll be able to spot like a very slight color change. It'll be able to find a very slight misalignment of elements. It'll be able to find a tiny 1 pixel offset. So for this, it is good. But here we're talking about UI UX in the sense of preparing the application to be the nicest experience possible for your end user. And for this, automation is not good, because it is not your end user. It is not going to actually give you feedback. Like, we have, of course, very elaborate tools which try and tell you stuff like that. For example, regarding accessibility, regarding color palette and stuff like that. But still, first of all, they're programmed by humans to try and adhere to a specific rules. And secondly, you still can't really do that when when the UI and UX are still in the phase that it's evolving very rapidly. And in such a situation, it's really not a good idea to leave that to automation. So very often you will like try and do the transition to automation at some point when your UI UX is on point and you are just checking for the, like I said, alignment, color, stuff like that, if it is to the pixel perfect with what you intended. But as for whether a human being knows what to do when they enter your website, then a machine can't really help you with that. Because if you tell the machine to follow some specific steps, it will do that. If you give it a set of guidelines and just tell it to check for them, it will. But still, all of this is just checking very numeric, specific values and making sure that they are as intended. But it is not the same as just allowing a real human being, be it a QA engineer or someone who just is a random person and will give you feedback, and just observing how they interact with your website. So for that, we can't really resort to automation. And the last example is going to be unstable applications. So maybe let's just say instability. So we've also talked a bit about that. Basically, when in this situation, I mean both the stability we referred to as predictability in our RPT, but also any other instability which may happen wherever in the tech stack. If your CI/CD pipelines are not really stable, if your application sometimes crashes or freezes and nobody knows why, if the servers sometimes act a little weird, it's not really a good fit for automation, because automation needs that predictability. It needs the environments, the application, and everything to be stable, because it can't guess. This is the main takeaway that you should have about the instability. It can't guess, it can't infer things, it can't work logically on things which it finds and doesn't understand. And so you should not use automation for unstable applications, because you are just wasting time. You are wasting, like I said, your time and the project's time, because you are wasting your time in the sense that the application you create, the scripts you create, will work well for a very narrow vertical slice of an application very often, which will change rapidly. And for the project, because your energy would be way more important and put to better use elsewhere. And so in such a situation, instability is a great marker for not being a good fit for automation. You should talk about how the eventual solution should look like. You should strive for getting some specific documentation, and the sooner you try to create an automation framework, the better. And very often, we should start as quickly as possible, but as quickly as possible after we are already agreed on something. Not when the UI is evolving every day and the locators are breaking and you are, like we talked before, both checking manually because it needs to be checked, and also fixing all your automation tests all the time, because then you are not even doubling your work. You are tripling, you are quadrupling your work with the same results, basically, because the pace of your fixes for your automation suite are not going to be able to keep up with the pace of the changes from the application, and it is going to be a constant hamster wheel of just running in place. So it's not really a good idea. When you have an unstable UI and an unstable application, you should not go for automation of that specific part. And so, like we talked before, a very important takeaway from all of this is that automation is costly. And by costly, we mean money, we mean time, we mean maintenance, and any other type of overhead that may come your way, because these are just umbrella terms, but very often under time, you may suddenly have, for example, DevOps needing to help you with setting up some CI/CD so that the tests are actually automated and they are run like they should. Under money, we mean both the money of the company because they are not really using their resources wisely, but also the money that the performance boost needed for the automation to operate properly entails. And for the maintenance, it is maintaining the script, both maintaining the script from you and the maintenance of, once again, the whole CI/CD from, for example, the DevOps team, and you having to talk with the devs and having to have calls with them because something is unstable. They are working on their thing. You are trying to keep up. You are constantly having this discussion, and very often it is not a pleasant one because something is breaking, you are angry, they want to work on something else, they are angry, and so it is not a lot of fun. And so you should remember that automation is costly. It adds some overhead every single time. So even though automation is good, it helps you to do a lot of things, as we have already discussed, it is still costly, and this needs to be taken into account. It's costly both in the material way and in the more abstract way. And so automation always equals overhead. And that's also something you should remember, that it always equals overhead. And if the thing that you are trying to automate follows the automatate, in basically most situations, then the overhead that is created and the time or the cost that happens in the beginning, you are going to make that up in the long run. So over a long period, the project will make up for the time, energy, efficiency, performance, maintenance time, and costs lost in the beginning. So in the end, project will take very good advantage from that, and when it like breaks even, it'll just go upward, because then the maintenance very often is not that long, and so it'll be able to run fast, efficiently, with less proclivity for error. But still, you need to remember about the overhead, and so you always need to weigh in the options and take into account whether what I'm trying to automate really is something that in the long run is going to be faster and cheaper resources wise than just doing it manually, if I'm doing it once, or if I'm not prepared to do it for some repetitive periods of time. And so with this, we can go to our summary. So for this, it'll basically be two main points. So one of them, the first one, is that you should not strive for 100% automation. As we discussed, it should be glaringly obvious by now why. Because a lot of tests are not a good fit. A lot of tests create more headache than they solve when doing automation. And very often, striving for as high automation level as possible is a gimmick. It's a metric that, like I said, you may be made to do this by your project, but very often it's not really a good idea because it's just burning time. So you should not strive for 100% automation. You should strive for 100% automation over the sensible material. So you should strive for 100% of automation over the things that automation is good for. You should not blindly strive for 100% of all the tests in your project being automated, because thinking that this will result in the tests actually being not in need of any operator overseeing them is a fallacy. It'll never happen. So you should not strive for 100% automation, because it'll look good in the metrics, but it'll be a real headache for the testers to upkeep. And even if they do, even if they give it their best, it'll still not be enough for such an automation suite to actually function properly, and it'll still need to be supplemented by manual tests. So you should never strive for 100% automation over the whole project just because it sounds cool. More is not better. More sensible automation is better. So you should automate everything that you can automate. And everything by can, I don't mean physically can. I mean by, like I said, good fits for automation. You should strive for 100% automation of the modules that are a good fit for automation. And number two, once again, is to evaluate your tests' readiness for automation through your RPT, which once again is repetitiveness, it's predictability, and it's tediousness. So this is the most important thing from this whole lesson. You should always try and evaluate your tests through the automatate before you get to automating them blindly. So you should not go for 100% automation. You should go for 100% sensible automation. And in order to know what is sensible and what is not sensible, you should do the automatate test. And in 99.9% of the situations, the automatate test will tell you the truth of whether something is a good fit for automation or if it is not. And with that, I leave you. I hope that this lesson has been informative for you. I hope that the automatate test will help you, and this mnemonic will help you to be able to swiftly and accurately evaluate the tests that you come across, and to be able to thus actually attack the problems that arise in your project, and to know which to automate and which you should just tackle manually and use up your resources elsewhere. If you have any questions, if you have any doubts, if you have any ideas, feel free, of course, to share in the comments and to subscribe to our channel and to follow us on Instagram. If you like the video, please leave the like button and see you in the next one. Keep on rocking.